All right, well, this is Tim coming at you from New Hampshire. We're here today on the Appalachian Trail. I'm actually sitting right on this famous trail. I figured this would be as good a spot as any to do this demonstration. And what we have here is a valley, very similar in some ways to the valley of Ravenna Creek in Seattle, where we normally do this vegetation lab. What we're going to be doing here is quantifying the vegetation structure in this forest, which occupies this valley. How do we do that, though? We can't measure every tree here. We could. It would probably take a lifetime, and it'd be way too much work. So we want to measure a subset of the trees. So in other words, we want to take a sample of the entire population of trees here. And we want to sample that subset of the trees in an unbiased way. Okay, so what are some ways that our sample could be biased here? Well, if I was not really thinking about it, I could go around and measure only the big trees because maybe I like big trees. Or maybe I could measure only the trees next to the trail because I don't really feel like walking off of the trail. This chipmunk is really not liking my video, or maybe he's liking it a lot. He keeps chattering at me here. So yeah, we want to be as unbiased as possible. We want to take human decision out of this equation. So one of the ways that we can do this, and it's the way that we are going to do it in this lab, is, I don't know if you can see, but I've laid out a tape measure here along the trail. And so we've got the sides of this valley going upward from the trail this way and upward this way. Along this tape measure, we are going to select a random number or a random distance. The tape measures we use in our lab are 50 meters long. So I'm going to take out my cell phone and use a random number generator app and find a number between 1 and 50. Okay. Then when I get that number, I'm going to find that spot on this tape measure, and I'm going to run a separate tape measure perpendicular to this one that runs up the valley this way and up the valley this way. Okay, and that's going to be our first transect for this lab. The second lab group, if we were doing this in person, would do a second transect, which we would determine with a different random number, presumably along the same line or a similar line. Okay, and that would be the starting point for a second transect, again, that runs up the valley side one way and up the opposite side of the valley the opposite way. Okay, so it's important that we get both sides of the valley here. That's really important because the north side of the valley may be very different from the south side of the valley. And if you've ever studied natural history, you know that in the northern hemisphere, north-facing slopes, in other words, the south side of the valley is north-facing, can be much colder than south-facing slopes, which get more sunlight. Okay, so south-facing slopes tend to be warmer than north-facing slopes. Okay, and as a result, vegetation can be very different on either side of the valley, so it's important that we get both sides. We're going to do 3 plots, one at the bottom of the valley, 5.5 meters from the trail, another plot partway up the valley at 30 meters, and another plot near the crest of this valley, near the ridge, I should say, at 55 meters. Okay, so it's really important that we get plots at each one of these different elevations, simply because at the bottom of the valley here we actually have a seasonal stream. Same thing in Ravenna Park in Seattle. Actually, the stream runs all year round, and many of the plants at the base of the valley are adapted to water, whereas the plants near the top of the valley, near the ridge, are more adapted to drought. Okay, so we can get very different vegetation structure from top to bottom, and depending on which side of the valley we're on. So we need to make sure we account for all of that in our sampling design, and we need to make sure that we are sampling in an unbiased way, especially with respect to where the transects start. And one of the temptations here and also in Ravenna Park is to simply lay down transects in areas that are easy to measure. Okay, so I might see, for example, up here there's a lot of cliffs and rocks, and maybe I just don't like hiking around rocks. So the temptation is to try and avoid that area and lay down a transect in an easier place. But if we're trying to characterize this valley in an unbiased way, this forest in an unbiased way, we really need to make sure that we're not simply avoiding areas that are unpleasant. Because when we think about wildlife, in particular the northern spotted owl or any other wildlife, those animals are probably not avoiding areas based on how they look or feel or how difficult they are for humans to hike in. Okay, so again, eliminating bias is the key here, and this is how we started off. And it turns out that my random number generator chose the number 1, which is right here, which means that our first transect is going to run uphill that way and across the valley and uphill this way. Okay, so this is transect number 1 here, perpendicular to my initial line. And in a second we'll get started on that transect, and I'll show you what it looks like.